we're starting this new unit, and the first thing we're going to talk about in this one is inverse functions. So this is really going to go back to what we talked about at the beginning of the semester about basic ideas about functions. We're going to start out with this function, 2 times the cube root of x plus 1. So some different things we can look at with this one are, for example, the domain and the range. We're going to do a lot of domain and range in this section. For the domain, we want to look at if there are any numbers that we couldn't put in for x. If this were a square root, we wouldn't be able to put in negative numbers. But if it's a cube root, we can put in negative numbers. There's no denominators that we have to worry about. So those are usually the 2 main things we're looking at, are whether there's something like a square root where we can't have a negative, or if there's a denominator where we can't have a 0. The domain for this would be everything. If we write it as an interval, it would be negative infinity to infinity. And for the range, look at the graph of this one. Okay, so on the graph we can also see that it's going all the way from the left end all the way to the right end. So that's the domain. For the range, we're looking at it going from bottom to top. And on this end, it looks like it keeps going down and out, and this end it keeps going up and out. So that means our range is also going to be from negative infinity to infinity. Let's just look at some function values, and we're going to pick some easy ones. We're just going to do a little XY table, and I'm going to pick some numbers that are easy to put into the cube root. Negative 8 for x. So if we put in negative 8 for x, we get negative 3 for y. If we put in negative 1 for x, we get negative 1 for y. If we put in 0 for x, we're going to get 1 for y. And then I'm also going to put in positive 1 and positive 8. So for positive 1, we get a 3, and for positive 8, we get a 5. This just gives us some different points that would be on the graph of this function. What we really want to do with this is talk about the inverse of this function. When we talk about inverses, the basic idea of these is that they undo what the original function did. So they undo it, or they reverse what the original function did. If we look at what's happening to the x in this one, we could go through and talk about each different things that happens to the x, different operations, and then we could think about how to reverse that, or how to undo that. If we look at our x, the first thing that happens to it is that we take the cube root. Then we take that result and we multiply it by 2. That's the next thing that happens. And then after that, we add a 1. That's the third thing that happens. If we want to undo all of that, what we want to do is figure out what operation would be kind of the opposite of each one of these so that it would undo it. And then we also have to think about what order to do the things in. I always think about putting on shoes and socks. If you're putting on your shoes and socks in the morning, you put your socks on first and then your shoes, right? When you undo that at night, what you take off first is the shoes. We're not just undoing these operations, we also have to do it in the reverse order. To undo this, we're going to start with this last one, and we want to undo that. To do the reverse of this, instead of adding 1, we want to subtract 1. If we've got any kind of operation, mathematical operation, we're going to use the opposite operation. If it's addition, then the opposite is subtraction. If it's multiplication, then the opposite is division. So then we're going to undo this one. To do that, we're going to divide by 2. And then last, how would we undo a cube root? What would make that cancel out? Yeah, if we cube it. Instead of doing a cube root, we're going to cube. What we really just did is we figured out what the inverse of this would be. And we can write this in mathematical terms so that we get an equation just like the one up here. We're going to start with our x. We're going to take that and subtract 1 from it. Then we're going to divide that whole result by 2. So we're taking all of this and dividing it by 2. And then we're going to take all of that and cube it. This is just these 3 things, put it into an equation. What this gives us is the equation of our inverse. And what we're going to talk about with these is inverse functions. If we want to write this with function notation instead of where I had the y equals here, that makes it just an equation notation. We want to write it with function notation. The way we say it's the inverse of our original one. If we had f for our original one, we just put a little -1 after the f. So this would say this is the inverse function of our original f. It's the same way as any other function notation, so the x is still the input value. This part here is just the name of our function. You can call it f inverse or the inverse of f. Let's take this and see what happens if we do an xy table with this one. And what I'm going to pick for values to put in for x, I'm going to pick the y values that I had up here. If I put in -3 for x in here, if I work that through, what I'm going to end up with is -8. If I put in -1 for x, what I'm going to end up with for an answer is -1. If I put in a 1, I'm going to end up with a 0. If I put in a 3, I'm going to end up with a 1. And if I put in a 5, I'm going to end up with an 8. So now what I'm trying to do is I'm going to go back and compare this to my xy table that I had for my original function. If I go back and look at these two tables, all it did was take and switch the x's and the y's. Here I had this column on this side and this column on this side. All this did was switch the two columns. All this is doing is it's saying if I put -8 in the original function, I'd get -3. My inverse is undoing that, so it's taking it back to the original number I put in. So it's going, instead of going from -8 to -3, it's going from -3 to -8. The idea of that is that inverses, we know that they undo what the original function did. Another way to think about it is that they switch the x's and the y's. So that's all we did from here to here, was that we switched those two columns. And what this does on the graph, I went ahead and graphed both of these. What this does on the graph is that it switches those x and y coordinate points. If we had a point that was on the original function, if we took the coordinates and switched them, that would be a point on the inverse function. So what we get is something like this, where we've got the two functions and they're actually reflections of each other over a particular line. It reflects across the line y equals x. And that's because we're just switching the x's and the y's, so that's why it reflects it across that line. But you can kind of see on this graph that we've got this one, if we flipped it over the line y equals x, I'm going to go ahead and graph that on there too. So there's our line y equals x. It's just taking this one and flipping it over that line to get the points on the other graph. Let's talk about something a little bit simpler. Let's look at a function that's just a few points. This would be one where these are the only points that are on the graph. We're not connecting the dots or anything. We just have these 4 points. We can still talk about the domain and the range. For the domain and the range for this, it's just going to be lists of numbers instead of being intervals. So our domain would just be all the x values. So it would be -2, 1, 2, and then we have another 1. The range is just the y values, so that would be 0, 4, 2, and -3. So one question we have to ask right away, since we're talking about functions, is does this qualify as being a function or not? For it to be a function, we can't have any repeated x values. And we've got this x value right here that gets repeated. So we've got one x value that goes to 2 different y values. That means it's not a function. So this is not a function because an x value is getting repeated. If we plotted these 4 points on the graph, it would fail the vertical line test because there would be a vertical line that would go through both of those 2 points. So we could also think of the vertical line test with this. Let's look at another one that would be a function. So for this one, if we look at the domain, that's all the x values, and this time they're all different. Right away, since we've got all different x values, we can say this is a function. For the range, we've got 3, -2, 5, and 1. And since we know this is a function, we're going to go ahead and figure out the inverse of this one. So for the inverse of something like this, you can't really do operations since we don't have a function rule or an equation to go off. So all we're going to do is take each point and switch the x and the y values. So for the inverse, we're just going to take each one of these and switch the x's and the y's. So 1, 3 is going to become 3, 1. 2, -2 is going to turn into -2, 2. 4, 5 is going to turn into 5, 4. And 0, 1 is going to turn into 1, 0. And we're not doing anything with pluses or minuses. All we're doing is just simply switching the x and the y coordinates. One other thing we want to think about when we do this, we've got this inverse here. We also want to look at whether the inverse would be a function. So let's look at the domain and the range for the inverse. So our domain is going to be all of our x coordinates. That's going to be 3, -2, 5, and 1. Those are all different, so that means yes, our inverse is a function. Our range would be all of our y coordinates, so that would be 1, 2, 4, and 0. Look at the domain and the range for the original and the domain and the range for the inverse. What do you see about those? They're just switched. When we switch the x's and the y's, the domain is the x values and the range is the y values. So when we switch those two, it just switches the domain and the range. So actually we could have written these two down just by looking at these two and switching them. We're going to look at one more of these. So let's write down the same things. The domain is going to be 4, 2, -2, and 0. Those are all different, so yes, this is going to be a function. For the range, we've got 1, 3, another 1, and 4. So this is a function because we don't have any x values getting repeated. We do have a y value that gets repeated. If we do our inverse for this one, we're just going to take each of these and switch the x and the y coordinates. That gives us 1, 4, 3, 2, 1, -2, and 4, 0. Now, when we already figured out on the last one that when we do our domain and range for the inverse, we can just take our domain and our range for the original and switch them. So for our domain for this one, it's going to be just 1, 3, and 4. Since we only have 3 numbers there, what that means is that we had an x value here that got repeated. And actually in this one, it was the 1 that got repeated. So what that means is that this inverse is not a function. We're always interested in whether things are functions or not. So that's kind of a problem when that's not a function. Our range would be the same as the domain that we had up here. So that would be 4, 2, -2, and 0. So what happened here that made this not be a function, we had a y value that was repeated here. That meant when we switched our x's and y's that our inverse turned out to not be a function. So we have a specific name for that because what we're trying to do with these is find inverses that are functions. So we want to know whether that's going to happen when we look at our original function. What we call this is whether we have a one-to-one function or not. A one-to-one function is something that's a function, so that means that we can't have any x values repeated, but it's also something that doesn't have any repeated y values. This has no repeated x values, which makes it a function, and no repeated y values. The nice thing about having a one-to-one function is that then the inverse is going to be a function. So if it is one-to-one, then the inverse will be a function automatically. But if it's not one-to-one, then we end up with something like this situation. So this function up here, it was a function, but it's not one-to-one because we've got a y value that's repeated. And when we're looking at graphs, we can look at a different kind of test to tell if something is one-to-one. So for our basic functions, we had the vertical line test to tell if something was a function. For the one-to-one, we have what we call the horizontal line test. And this just tests whether y values get repeated. It works the same way as the vertical line test. So in other words, if we have something like this, we're looking at whether a horizontal line would ever intersect this more than once. So this one, there's no horizontal line that we could draw that would intersect it twice. So this one, we'd say it passes the horizontal line test. That means it is a function, yes, and it's also one-to-one. On the other hand, if we had something like this is a function because it passes the vertical line test. But if we do the horizontal line test, there are lots of places in here where a horizontal line would intersect this more than once. So that means it fails the horizontal line test, which all that's saying is that there's a y value that gets repeated. It's not one-to-one. And what that means is if we looked at its inverse wouldn't be a function. So we could still find an equation for the inverse of something like this, but that equation wouldn't give us a function. Now we're going to look at some different equations. So instead of just looking at a bunch of points, we're going to look at some equations, and that way we can see what the graphs look like, how they reflect across that line y equals x. So we're going to start out with a pretty simple equation here. So the first thing we want to know about this one is whether it's one-to-one. Usually the easiest way to do this is going to be just with a graph. So there's the graph of our function. Yeah, we can see it's one-to-one. There's no place that a horizontal line would intersect that more than once. So this is one-to-one. We also want to think about what the domain and the range for this function would be. If we look at the graph, notice the graph starts right here where our x is 0. So our domain, if we do interval notation, it's going to be 0 to infinity. How about the range for this one? Can you tell from the graph? Yeah, it's actually going to be the same thing. If we go bottom to top, the first point we come to is that 0.00. So that's where our range starts, and then our values out here are going to keep going up. So also our range is going to be from 0 to infinity. So now we want to think about what the inverse would be. So the only operation that we're doing to the x here is doing the square root. How would we reverse that or undo it? So we would just square. We would just say our inverse equation is y equals x squared. Now when if we do the graph of that though, so if I add x squared to my graph, I'm also going to put y equals x in here so we can see that reflection. When I do that, I'm getting some extra stuff over here that I really didn't want. If I just ignore that part, then right here I've got my original function, and that's its reflection across that line y equals x. So I really don't want to have this half of that parabola over there. If I look at my domain and my range for my original function, to do my domain and range for my inverse function, I'd just be switching these two. So what that means is that for this one, my domain isn't going to be negative infinity to infinity. I want to leave part of it out so that I'm just getting part of that parabola. My domain is going to be the same as the range I had here. So my domain is only going to be from 0 to infinity, just so that I can make it the actual inverse for this function. So what we call this is a restricted domain. Because normally the domain for this function would be from negative infinity to infinity. We're only taking part of that. We're cutting part of it off. We're saying that's a restricted domain just to make it the inverse of this one. So I fixed it on my calculator so it would only draw the graph with that restricted domain. So now I've got my original function, and this one is just a reflection of that over that line y equals x. Okay, now let's start with this equation. So we're going to go through all the same stuff with this one. First we want to look at this and see whether it would be one-to-one. And you can probably guess this isn't going to be one-to-one because it's going to give us a parabola shape. This is not one-to-one because we could draw horizontal lines through there that would intersect it more than once. So if we want to go ahead and talk about an inverse for this one, we're going to have to do something to make it one-to-one. What we can do is we can restrict the domain just like we did for this one up here. So we can decide what part of this function we want to keep and what part we want to throw away. And we can just say what we want our x values to be. So one way we could do this is just to take the right half of the parabola. So we could say that x is going to be greater than or equal to 0. We could do that. If we wanted to get fancy, we could even take the left half of the parabola. So we could say x is less than or equal to 0. Or we could even take a smaller piece, as long as the piece that we're going to take is going to be one-to-one. So let's just do this the easy way and just take the right half of that parabola. So we're just going to take the right half of that. So to do that, we're going to say that we're restricting our domain to just be from 0 to infinity. So what we're doing is restricting the domain, so that erases this half of it over here. And now what we've got is one-to-one, because now it would pass the horizontal line test. So now we can talk about an inverse of this that would be a function. And what we want to do is find that. So let's think about what operations happen to the x. What's the first thing that happened to it? Okay, yeah, the first thing that happened to it was we squared, and then what happened? Yeah, the second thing was that we added 3. So we want to reverse both of these in the opposite order. So that means the first thing we want to do is subtract 3. And then after that, we want to do the square root. For our inverse equation, we're going to take x minus 3, and then we want to take that whole thing and do the square root of it. So we would put the radical over the entire thing. So I'm going to put this equation in here just to make sure that it turns out right. Here's my original function. Here's my inverse down here. And we've got matching points that go from this function to this function, where we're just switching the x and y coordinates. So you can see it's reflected over this line y equals x. So now if we write the domain and range for our inverse, we restricted our domain on this one, so that means that that's going to be our range automatically for our inverse. So we know our range is 0 to infinity. We didn't actually talk about the range for this one, but we can see on the graph the range for our original would start at 3 and go up, or we can see the domain for our inverse would start at 3 and go to the right. So our domain for this is actually 3 to infinity. So if we wanted to go back to this and say what the range of this would be, it's going to be the same as the domain for this one. So one more thing that we need to talk about, the way we've been doing this so far to figure out the equation for our inverse, that works if you've got fairly simple things like this, but if they get too complicated, then that way is really hard, or sometimes probably impossible to figure it out that way. So there's also an algebraic way to find the inverse, the equation of the inverse for something. So let's go back to the very first one that we talked about. We already figured out the inverse for this one, but we're going to look at how to do this with algebra. So to do this with algebra, the first thing that you want to do is write it, instead of with the function notation, you just want to write it as an equation. In other words, instead of the f of x over here, just make that a y. So that's the first step. Then the second step, because our inverse is going to switch x's and y's, we're going to take the equation we have and just switch the x's and the y's. So any place there's a y, we're going to replace that with an x. Any place there's an x, we're going to replace it with a y. This is actually an equation for our inverse already. So this would give us an equation for the inverse. The problem with it is that it's not solved for y, so we wouldn't be able to put it into our y equals menu. We wouldn't be able to graph it this way. So if we want to be able to graph it or write it as a function, we need to solve this for y. So we're going to take this equation and solve it for y. And just think about basic equation solving principles. What we need to do first is get our cube root by itself on one side. So we'd have to start out by subtracting 1 from each side. That gives us x minus 1 over here. Then to get rid of the 2, we'd have to divide both sides by 2. Now we've got our cube root by itself on one side. To get rid of that cube root, we're going to have to cube both sides. Now we've got this solved for y, and this gives us an equation for our inverse that we could put in our calculator. We could also write this in function notation. So for function notation, instead of the y, we'd write that as f inverse. Like that. Let's go back and do that also with that last function that we talked about. We wanted to use algebra to find the inverse for this one. Then we've already got it written as an equation, so we would switch the x's and the y's. That would give us x equals y squared plus 3. Then we would want to get the y squared by itself on one side, so we would subtract 3 from each side. And now here's where it depends on how we restricted our domain in the first place. This was the one that we took only half of our parabola, because when we take the square root of both sides, normally we would have to do plus or minus on this side. So technically, if we solve this by doing the square root of each side, we'd have a plus or minus over here. Here's where we'd have to choose one or the other. We can't have both. In this one, because of the way we restricted the domain, we would just take the plus. If we had chosen the other half of our parabola, then we'd end up with the minus square root instead of the plus square root. Let's look at one more. Some of these, like I said, they get kind of hard for finding the inverse. For this one, we've got a rational function. We would know some things about our rational function, but we don't know without looking at it whether it's one-to-one or not. So I'm going to put it in my calculator so I can see what the graph looks like. Okay, so this looks like a rational function. We can see there's a vertical asymptote. It looks like there's a horizontal asymptote. What we're interested in is whether there's a horizontal line that would cross this more than once. It doesn't look like there is, because it looks like this kind of jumps over that horizontal asymptote. We can say this one's one-to-one. So to find the inverse of this, this is one where it would be really hard to find it with that other method where we're just talking about what happens to the x, because we've got lots of different things happening to it. So this one is going to be easier to use algebra. So we would switch the x's and the y's. That would make this 3y over 2y plus 1. And now we want to solve this for y. This is kind of like the problems we were doing in that last unit. So this is one, if I want to solve this for y, I'm going to think of cross multiplying. So I'm going to have x times 2y plus 1 equals 1 times 3y. On this side, I'm going to go ahead and distribute my x. Since I'm trying to solve for y, that means I want all my y terms on one side and everything without a y on the other side. So I'm going to subtract the 2xy from both sides. So that on this side I just have x, and this side I have 3y minus 2xy. Then since I've got two terms over here, I'm going to factor out the y. That gives me y times 3 minus 2x. Now I can divide out this whole factor. That way it's going to cancel on this side, and now I've got my equation for y is x over 3 minus 2x. So here would be my inverse equation.